Welcome back to my Unreal Engine 5 Tetris-Like tutorial. Today we're going to be working on the collision for the Tetra Minnows. So to do that, we're going to have to go into the block base and then work our way up to the Tetra Minnow base. So originally, let me see here, my hotkey to open up the CPP file is Alt-O. I can't remember if I mentioned that before. It's a very useful thing. What's up all these comments and stuff in here? Don't need all that. All right, I don't think we need tick on block base. But what we do need is an isColliding function. So let's see how I did it in the CuboMinnow project. Oh, that's right. So I just had a Boolean that is colliding, and it just returns that. So let's grab this first. That was public. All right, so I just made it force inline because it's basically just a return statement. But this also means I'm going to need the protected B isColliding Boolean. B colliding, and we'll just default it to false. All right, so we got that, but then the next thing we need to do is set up the on component begin overlap. So we need it on the block collision, obviously, because that's what's going to be colliding. So let's grab these, and there's something important about that that I'm going to need to point out in a moment. Block collision, okay, so that's what we named it, the same here. All right, so in order to use this on component begin overlap on the uBox component, you have to do something special to make a function callable by this. So in order to do that, to see what you need, what I like to do is I just hit Control and go on this on component begin overlap, and it shows you that you need a F component begin overlap signature, which is this signature right here. So it's using like a macro to define it, but basically this is the name of the function. It's a U primitive component. That's the name of it. But the actual signature itself is everything after that. So you have to copy all of these and make them be the inputs for your function, or the on component begin overlap will not sense it. So with that out of the way, what we need to do is make a set colliding and unset colliding function. Actually, you know what? Let's go in here. Set colliding and set unset colliding. Well, I made these U functions, but I don't think they need to be. I'll take that off on this one. So those can be protected. We'll put them in after begin play. I don't believe they need to be U functions. All right, and then U primitive component. Well, it looks like I forward declared it twice. Not necessary. Let's just stick our forward declaration up here. U primitive component. Control H. All right. Know that we actually need declare a actor. No, we don't. So anywhere where I see class A actor, redundant. So remove the part that says class. Oh, it's only in those two spots. All right, so we got U primitive component, A actor, int32, bool, an F hit result. That's a struct. I'm not sure if that's gonna complain or not. Let's check back over here. Static mesh, box component, ismet, math library. All right, so it doesn't look like I needed to forward declare F hit result or anything like that. All right, so we can generate functions for these. Not sure why it put them above tick. Actually, this doesn't even need to tick, so let's just remove that completely. Okay, so we got B is colliding, set colliding, and unset colliding. And then in these, all we're doing is when we're setting colliding, we're setting B is colliding. What did I name it? B colliding. B colliding equals true. And B colliding equals false. All right, and then we did define is colliding. All right, wonderful. Okay, so let's error? Not sure what that's about. Let's build. See if we missed anything. Okay, all right, that works. So then in tetramino base, we're gonna need an is colliding function as well. And all that is gonna do is check the 4 blocks. All right, we can close these. We're back in cubomino. So now we need is colliding from here. And that is going to be public. All right, and then is colliding. All right, so we're looping through the 4 blocks, checking each block if they're colliding. Oh, so we're doing some stuff checking if it's dropping yet. Probably gonna have to comment some of this out, at least for the time being. All right, so if the block is colliding, we're returning true. The rest can wait until we're doing a drop. And then if we get through the for loop and we still didn't return true, then we return false. Okay, and that should be it. All right, so let's build. Fantastic. All right, so the next thing is, now that we know if we are colliding, we're going to need to work on this check set revert position. Yes, so if it is colliding, wait, if it is colliding, I would think if it's not colliding, then we want to set position. Check set revert. Maybe I just had a bad name for it. Oh, I see what I'm doing. Okay, so we're setting position in move. We could ignore dropping for now and finding the best rotation. Um, but if it is colliding, then we want to revert it to the previous position. So let's we'll have to rename this to previous position. All right, so we're in Cubominnow. We have is colliding, so now we need check set revert. I don't think we need block base open anymore. We need primitive component. Okay, and then check set revert, I believe, should be protected. Yep, all right. So protected, we'll stick it here. Generate definition. Grab these. I want to call this previous position. Let's change that over here as well. It's a little bit more descriptive. Okay, good. So now in the move, oh yeah, we also need to set up this move buffer. I believe that would be protected as well. Now the move buffer is just the size of the area or the distance that your mouse cursor has to be away from the tetraminnow before it will move again. All right, and then that is also protected. Right, so we did grab time between moves. All right, that's all set. We'll just stick it under orientation, same as it was before. All right, back to the thing. So we'll leave off B is dropping for now. We'll handle that in another video. In the meantime, we can uncomment this. Comments here. Oh, yeah, still gonna need that. This looks like a lot of reused code. Oh, maybe it does need to be out here. So if input location X less than previous position X minus the move buffer. Yeah, because once we get to move, we're no longer in a land where we know X and Z separate from each other. Yeah, and here it's input location Z greater than previous position Z. Okay, so I'm going to go through and do the same thing. I won't make you watch me uncomment and recomment certain things, but I'll be right back when I finish that. All right, I finished commenting out the B is dropping Boolean for each of the move up, down, left, and right. Then I also went up here and I uncommented the check set revert position, which now exists. And if it is colliding, then we'll set the position back to the previous. All right, so I think we can build and launch the editor in debug mode, and let's see what we got. I'll be back in the editor. Okay, so it turns out I still need the U function, or yeah, U function. These will not work without it. They cannot be bound. So Alt O. Yeah, so to use on component begin, overlap, add dynamic, whatever function you pass in here has to be a U function. All right, so let's try this again. Okay, the moment of truth. Let's hit play. And oh, we have collision. Look at that. Wonderful. Okay, so the next thing we'll do is probably the drop. Yeah, probably the drop. And maybe we'll tackle the auto rotate function next as well. But for now, I'm going to end this here. I hope you enjoyed this video. I'll see you in the next one.